In this video, I'm going to talk about the ISIS neighborship and neighborship conditions and some features about the neighborship, for example, authentication. Let me start with this scenario again. This is the scenario I configured in the previous videos, and you learn about the configuration of the routers for ISIS. For example, we configured the net address on every router, and also we configured the level of routers, level 1, level 1, 2, or level 2 only. And also we learned how we can configure the circuit type in every interface of the, for example, level 1, 2 router. In previous videos, also we learned the content of the topology and also the database in every router. In this video, our focus is the neighborship, how neighborship is establishing, and what is the required parameters or neighborship conditions in the ISIS. It's so important for us to learn how ISIS establish neighborship, and after that how ISIS maintain the neighborship. Why? Because you know that this is the first step in the ISIS process. And because of that, when you have a problem in the exchanging routes in ISIS, the first thing that you should for example, think about that is the neighborship process. And you should know that in ISIS, which parameters should be same or should be not same between the routers to ISIS can establish neighborship. Because of that, this scenario is one of the important scenarios for troubleshooting also. Okay, let me to start talking about the ISIS neighborship. The first things that we should know is the ISIS adjacency states. Let me to talk about the ISIS adjacency states. After that, we can start the conversation about the detail of the neighborship, the required parameters and required conditions. In ISIS, we are using different packets for different usage. For example, we are using hello packets for establishing neighborship and also maintaining neighborship. And also we are using other packets, for example, LSP or link state PDU for exchanging the link states. Now we are going to talk about only the hello packet of the ISIS. Why? You know that for establishing neighborship and also for maintaining neighborship, ISIS uses only the hello message. Because of that, in this video, we will talk about only the hello message of ISIS. But in the future videos, you will learn about the other message of the ISIS and their function. Let me to start to talk about the ISIS adjacency or ISIS adjacency states. You know that when we have two routers connected to each other directly, they should send to each other hello message, and after that they can find or discover each other, and finally every router or each router can compare the parameters of the received hello message with the parameters of itself, and after that they can establish, for example, neighborship. Let me to talk about this process first with the overview, with the high level overview. Okay, you know that in every protocol, for example in OSPF, again we have adjacency states. Here also in ISIS we have adjacency states. Look at this part of the scenario. Look at here, this is the ISIS adjacency states. In ISIS we have only 3 states, less than the OSPF states. The first state is down state. The second state is initializing or init state, and the third state is up state. Only in ISIS we have only 3 states. Let me to talk about the, for example, first down state, then initializing state, and finally up state. Look at here, we have two routers, R1 and R2. Both of them now are in down state. Down, what does this mean? Down state means this is the initial state. It means that no hellos have been received from the neighbor. Look at here, in this state, R1 doesn't receive hello from the R2, and R2 also doesn't receive hello from the for example, R1. This is the down state. In down state, we don't receive any hello message from the neighbor. Because of that, we don't have any neighborship relation with the, for example, router, the neighbor router. The next step is init or initializing state. This state means that the local router has successfully received hellos from the neighboring router. However, it is not sure that the neighboring router also or has also successfully received local routers hellos. Look at here in this part, R1 in down state, for example, sending the hello message. Include in the hello message or inside of the hello message, we have the state of me is down. This hello message received in the for example R2. Because of that, R2 now is in the initializing state, because R2 received successfully one hello message, but it doesn't for example sure that or ensure that R1 also received the hello of R2. Because of that, now R2 in init states. After that, for example, in the next hello message, R2 should send its hello message with the init state, because the state of R2 now is init. When R1 receives the hello message, okay, of the R2, it can see that the init state now is available in the hello message. Because of that, now R1 should go to the up state. Why? Because up means now it's confirmed that neighboring router is receiving local router hello. Look at here, because R1 knows that the R2 is in the init states. This means that I can, for example, ensure that R2 received my hello message. Because of that, R1's state now should change to the up state. And after that, as you can see here, R1 should send its hello message again, and with the state of up in the hello message. Because of that, R2 now is ensured that the R1 received the hello of the R2, because the state of R1 is up, and finally R2 should go to the up state. As you can see, this is a three-way handshake of the ISIS, not three-way handshake of TCP. This is the three-way handshake of the ISIS. Okay, let me to review the states. First, down. What does this mean? What is the meaning of the down state? This is the initial state. It means that no hellos have been received from the neighbor. The next step is init or initializing states. This state means that the local router has successfully received hellos from the neighboring router. However, it is not sure that the neighboring router has also successfully received local routers hello. And also we have another for example state, the up state, the last state. Now it is confirmed that neighboring router is receiving local routers hello. And as you can see, finally both of routers should has the, for example, up state, and after that they can use the hello message for maintaining neighborship. You know that in ISIS, such as some other routing protocols, for example OSPF or EIGRP, after establishing neighborship, the protocol uses the hello message for maintaining neighborship. Okay, in ISIS we have the same process. In ISIS, after establishing neighborship, each of routers, for example R1 and R2 in this example, should send its hello message in the specified intervals. We call it hello interval. And after that, we have another feature, we call it hold time or dead time. Okay, and when one router doesn't receive any hello message from its previous neighbor in the specified hold time interval, this means that that neighbor now has down state, or that neighbor now is dead. Because of that, the neighborship should be tear down. This is the same process of the, for example, between ISIS and other protocols. In ISIS, we have the hello timer as 10 seconds by default, and also we have a feature, we call it hello multiplier. Hello multiplier by default is 3. This means that if you didn't receive the hello from your neighbor in 3 times of the hello intervals, means